Hey there, folks. Hope everybody can hear me here. We're going to get started. So today we're going to be talking about why, or why so many cloud platforms feel duct taped together, really what to do about it with real best practices from dozens of IaC projects. My name is Matt Gowie. I run a consulting firm called Masterpoint. Our entire focus is infrastructure as code. We are really driven to help our clients migrate, automate, and innovate their infrastructure as code setups. And that is what we do. So we've been working with Terraform, OpenTofu since 0.11 with clients that range from startups to enterprises, Fortune 500, and really have seen it all. And that's where a lot of this experience comes from, where a lot of these best practices come from. And this talk is about cleaning up messy cloud platforms with better IaC practices. And I want to start off with, why are we talking about infrastructure as code in the context of platform engineering? So let's begin there. Cool. So if we look at some data, our friends at Humanitech, who are also speaking at this conference, they put out the State of Platform Engineering report. And if we look at that, we can see that, hey, IaC is the top one, right? We have a bunch of different things on this list, but when platform engineers, when DevOps engineers are asked about what is the area of focus, they say IaC is the top one. So that feels like, hey, regardless of if you're running Kubernetes or you're doing NoSQL or SQL, you're using infrastructure as code to ship that infrastructure. And it's a huge part of the platform engineering story. It's how we're actually delivering value. So that is why we're talking about that today. It's extremely important. And even though IaC is everywhere, the reality is that most platforms are really still a mess. So let's talk about why. So I think we need to admit this, and I think that we're still early in the platform engineering journey, but yeah, that there's this idea that most platforms feel duct taped together. There's lots of glue, right? And I think that comes down to there's a ton of chaos around too many tools, cowboy pipelines, duplicated effort, and there's this lack of applying our best practices that we have elsewhere. And that results in us not being able to move quickly, not being able to have guardrails, and not being able to retain control over what we're doing. So what we're going to be talking about, and what is the real problem here, is that I don't say that the tools are the problem. I would say that their implementation is. The way we might misuse them or use them really creates this inconsistent glue. We get bespoke solutions, inconsistent patterns, unclear ownership, and that's what bogs us down. And this talk is my answer to that question. This isn't really about chasing any trends or anything. It's about, hey, let's commit to some essentials, say that, hey, we need these things, and follow some best practices. So this is coming from lots of experience across many infrastructure as code projects over many years, across a lot of different setups. One of the first causes of platform chaos is teams using too many tools. So let's start there. And my suggestion to all of you is pick a tool. I think that what we've seen is that if you don't standardize, you end up drowning. I'll give you a quick example from a client. We did an audit for a client recently, and they were using many infrastructure as code tools. They had a README document that shared, hey, we use Terraform in this case, we use CDK in this case, we don't manage these resources because we're afraid we might delete them. I call that fear of resource deletion, and that's something I'll talk about. But they had this list of when do we use which tool. And I think it was causing their organization to not be directed, to not be pointed. And they then didn't have strong consistency. They didn't have strong expertise in one tool. And it caused them to just really be floundering in being able to execute well with any of those tools. So from a practical standpoint, I will always suggest hey, a lot of this talk today is about Terraform or OpenTofu. A lot of these suggestions can translate to any infrastructure as code tool. But I would suggest you pick one of those tools. We always suggest OpenTofu. It has the best ecosystem, and not a combination. And I would really also suggest about going back to this fear of resource deletion. Hey, if you're afraid that your infrastructure as code is going to delete a database, and therefore you have an engineering leader who's saying, no, we cannot use infrastructure as code to manage our databases or our clusters or something along those lines, there are ways to solve that, folks. You should really put the proper controls in place to avoid those types of issues. There is role-based access control that'll help you, where you can say, hey, this is not being able to be deleted by infrastructure as code. There's also just deletion protection mechanisms around a lot of the cloud providers that enable you to say, hey, this needs a second step of confirmation before it's deleted, so you can't actually delete it. And yeah, don't fall into that trap. Really, this is a simple one, right? So now that we've covered tool standardization, let's talk about where teams waste a ton of time, and that is pipelines. So when we talk about automation with our clients, our suggestion is to buy and not build themselves. And I think I really empathize with all the engineers who want to build their own pipelines, who want to create their own custom solution. I'm an engineer as well. I love building things, but I'll ask you folks to ask yourselves a question, or maybe it's a better question for your engineering leadership. Go and ask your engineering leaders, what is the most expensive resource in your engineering organization? And I am going to say that the likelihood that they tell you that it's you, your time, your hours you spent at your computer building something is likely your most expensive cost to the organization. That answer should show you that, hey, if you're spending hours upon hours and sprints upon sprints building custom pipelines for infrastructure as code, you're not creating a competitive edge. You're kind of wasting your engineering organization's time, and you're delivering a subpar product. People have different opinions on this. We have a strong one, but I would really recommend you at least think about buying. Don't write it off as a non-possibility. From a practical sense, go out and check out the TACOS tools. TACOS stands for Terraform Automation and Collaboration Software. We're talking Spacelift, N0 Scale, or Terramate, Terrateam. These are fantastic, awesome products. They do really good work. I would really highly recommend you check them out. If your organization is completely against doing that sort of thing, they do not buy software for some reason, they're willing to pay you 6 figures, but they will not pay a $500 a month tool, then go and check out open source. You can run Atlantis yourself, Tofu Controller, Burrito. There are awesome open source ways to automate infrastructure that you don't need to reinvent the wheel. And that is the biggest suggestion I would make to you is there is ROI on not building things yourself. While we're talking about building things, let's talk about something else that teams love to reinvent, which is modules. And my big thing on modules is, again, don't reinvent the wheel, right? I will also, again, repetitively ask you to ask yourself a question. How is your infrastructure different from your competitors? That is a question I want you to think about, because to me, we go into infrastructure projects all the time with different clients. They're all shipping the same ALBs, the same databases, the same policies. The thing is that if you are going and creating your own internal modules, you are reinventing the wheel. And yes, you're able to customize that as much as you want, but you're also having to put a ton of work into the beginning of that project and then also the maintenance of it long term. What I usually say to people is this is like a house analogy that we always use in software. I love the house analogy. Hey, your software project is like building a house. If you're using open source, you're using prefab components. You're taking a wall and you're placing it exactly right. And hey, it already has your door, it already has your window. If you're using internal only, if you're building all of your modules from scratch, you're building that house brick by brick. And that means, hey, you're going to need to stucco that wall in a little bit later. You're going to need to, maybe change the direction of that window. Those things are going to slow you down and make it so that you have a worse platform. From a practical standpoint, what does this mean? I would always just suggest to you, avoid the costly build out and maintenance of internal modules and pick a popular open source module library. We're really big fans of the Cloud Posse modules. We're contributors and maintainers, my team and I, and pick one of those, stick with it, use it to your advantage, contribute to open source, and you will benefit. Now that we've touched on modules, it's time to talk about the philosophy of how you need to treat infrastructure as code. And I will stipulate to all of you that we should no longer be treating infrastructure as code, as config. We should be treating it as code. Treat it like software. It is software. What I'm really getting at there is that we go into a lot of client environments and they are copying and pasting directories. And that is their means by which that they deliver new infrastructure as code projects. Maybe they have some child modules, but for a lot of the time they're doing dev stage prod and they copy and paste directories, and that's how they move progress across their different projects. And I think I understand the idea behind it, because if you look back at early Terraform, or if you look at CloudFormation or other infrastructure as code tools, there really wasn't the capabilities to easily replicate those root modules, those projects, Terraform projects, to different environments, and you didn't have a good means by which to do that. A lot of people wrote wrapper code. They developed a way to do this so that they could create infrastructure kind of in whatever way they could, using it as config. But today, from a practical standpoint, I will say always design for reuse, and really create reusable and tested child modules. If you're using open source, you usually don't need to do this as much, but create also reusable root modules that are maybe service oriented. You can really create root modules through that, deploy one thing and deploy it well, and then take workspaces or OpenTofu's dynamic backends and use that to roll that out across your different environments, across your different teams. You're not then creating a huge maintenance burden for yourselves in terms of having a ton of infrastructure as code that's copied, and you then need to do what I call find and replace development, where you're searching across all your code bases to fix things. That is not a good way. That is not a sustainable way to build infrastructure as code, to build reliable platforms. So speaking of taking something, seriously, like infrastructure as code, the next one that constantly gets ignored, but it's critical, is naming and tagging. I consider this a bit of a superpower. It's funny to me that we always come into clients and we introduce this idea, and usually they really like it, but it's hard to implement after the fact, but it's possible. I'll kind of go through my example here, but the idea is that, hey, we want to implement a pattern, enforce it, and then really stick to it. Make sure that everybody in the organization is using it. So here, my example is this data-eng US East 2 prod analytics DB reader. If you see that, hold on a second here. If you see my cursor, no. I guess you can't see my cursor, never mind. But that example is what we call a label. And that is a namespace, a region, an environment, a name, and some attributes. Some of those are optional, but you can take all those components to this label. You can make that the name of the resource that you're building, and then all of those components become your tags. And this is essential for finding ownership of who owns what in an organization. It's essential for financial operations. If you have a CFO and they're looking at your cloud bill, they will appreciate you for this one. But it's also just a way to keep things organized. And yeah, there's plenty I could say about this. I could give an entire talk on it, but this is the label module pattern. This is the scalable way that we do things. I would suggest you Google Masterpoint null label, and you'll find a couple blog posts that we've written on this. I'll also be sharing these slides, and you'll be able to click that link. But Cloud Posse has the Terraform null label module. We build on top of that. We're big fans. I would highly suggest checking it out. So next up is how do we do security and ensure quality? And let's look at CI pipelines for your IaC. And I loved Robert Hafner's talk just a little bit earlier about taste testing tofu. Did not know that was going to be about testing. I didn't maybe read the description, but his talk is this slide. Go and watch his talk. It's fantastic. I really enjoyed seeing that because, hey, everything I list here, he hit on and he goes into depth about it. And I think that our two talks pair really well together. But I'll just start here and say, hey, your IaC CI should always include these 5 things: security, formatting, linting, testing, and documentation. And really, I'll hit on security. I think that, go and get a thorough review from Robert's talk. I think it's fantastic. But I think if you're not, I'll just say one thing about these things. If you're not doing security for IaC today, you're not like static analyzing your IaC code, I kind of believe you're being negligent. IaC it lends itself so well towards static analysis from a security perspective that we have a really good way to catch issues that could happen in production from a compliance perspective, from a hacking perspective, early on in our lifecycle, in our IDEs, that if you're not doing this today, I would say that should be your number one thing that you go and tell your boss tomorrow that you need to have this done. It is a critical piece to ensuring infrastructure as code is secure, quality, and really does a good job. These other things are also really important. I'm not going to hit on them too much. I'm just going to keep plugging Robert Hafner's talk. Go and watch the video of that if you did not get to see it. And we'll move on to our last one here, though. So even with the perfect CI, the thing that will still drag you down is giant bloated infrastructure as code projects. We call these teraliths in the IaC world. My team and I have talked about this a ton. It's one of our things that we see all the time and we need to deal with all the time for our clients. So one of my biggest suggestions is break up the teraliths. What is a teralith? For those of you that don't know, it's when you have too many resources in a root module, in a state file. And what that results in is you end up with slow plan and apply times. You end up with role-based access issues, and you end up with huge blast radius concerns, where you cannot independently work on some set of resources without potentially affecting another set of resources. And this ends up slowing down organizations. And I'll give you an example from another client. We went into an organization. They weren't that large, but they had one root module that had 40,000 resources in it. And that caused that root module to plan so slowly that it was taking a half hour to an hour to plan, half hour, an hour to apply. At a certain point, that root module just started to fail. It would just run out of memory because Terraform Cloud couldn't give them enough memory. And that was an extreme example, but that was a critical component of their business. It was how they onboarded clients. We have like a case study that's written up on this, and it's very in depth. But I think that it really just shows you that, hey, if you're not planning your infrastructure as code root modules well, you can really end up getting into a position where things start to blow up. And that's what I want you folks to avoid. So what I'll say is build reusable root modules with tight scopes and clean interfaces. And those root modules should be repeatable. You don't want to have to tell everyone to be building their own root modules all the time. You end up with a ton of small snowflakes. What you want to do is you want to build root modules that really are just driven by the variables that you pass in, and then you're able to move forward with something that you can take to another team and say, hey, here's how we deploy databases. Hey, here's how we deploy a Kubernetes cluster. If you want a step-by-step guide on breaking up teraliths, if this sounds like something that you're dealing with, feel free to Google Masterpoint teralith. We have 2 blog posts on this topic, one that talks about what a teralith is, 2 that talks about in-depth steps to break this up, gives you a checklist, all that good stuff. So now we have a bunch of practices that I've said, hey, go and do these things. How do we bring all these things together? Here's a quick recap. Oh, one more, one slide too fast. All right. So thanks for sticking with me. Let's recap on what you should be doing. To boil it down, I would say you're really going to want to pick up a single tool. Pretty simple. Skip writing your own IaC pipelines. Go and evaluate the tools that are out there. They're really fantastic. Lean on open source modules. Really go and evaluate open source. Try not to build things in-house when you know you're reinventing the wheel. Build for reuse. So avoid copy and pasting directories of IaC code. That is not a sustainable approach when you get into IaC at scale. Implement a naming and tagging policy. Practice good IaC testing and CI, and avoid the dreaded Teralith. If you follow all these things, it'll really help you clean up your platforms, really help you successfully deliver on that platform engineering promise of being able to do self-service, of being able to give your application engineers a platform that they're going to be able to take and run with. And I think that's what we've seen. That's coming from this standpoint of working with many projects, many clients. So thank you so much, folks. I really do appreciate your time. It's really been awesome to share all this. I'm interested in the feedback. And yeah, these are topics that my team and I talk about constantly. We're on LinkedIn. You know, we have a very active blog and a newsletter as well. Please be sure to follow along. I think you can get all those links at this QR code. You can get them at that link. You will also be able to get these slides later. And yeah, if any of this sounds daunting to any of you, like this is too many practices, I just hit on a bunch of pain points that you're dealing with, let's chat. Feel free to reach out. I'd love to take you from messy to mature and help you move things forward. Thanks for the time, folks. I hope this was helpful. And yeah, I'm happy to answer any questions.
All right, so we've got a question here from David. So what's the value proposition of a talkless platform of investment in traditional CI/CD? What's your take on this one?
So is it just another tool that teams should consider avoiding? So yeah, I would say that the issue with investment in traditional CI/CD is you're building your own custom thing a lot of the time, right? Infrastructure as code is unique within CI/CD because a lot of the time we're not just deploying one application, we're deploying many small projects. When, you know, I talked about breaking up Teraliths and creating reusable root modules, you end up having a ton of things to deploy. It's not just one application or a dozen applications that you need to deploy. When you're working at scale with infrastructure as code, you're working with hundreds, thousands of root modules that you need to plan and apply. And I think if you're trying to manage all of that within a CI/CD platform, it ends up being kind of complicated if you're building your own custom solution. I will also say the state requirements around needing to review a plan well and being able to say, hey, these stacks, these root modules need to be reviewed for dev and stage, or they don't need to be reviewed for dev and stage, but they do need to be reviewed for production. There's certain things like that that are just, they're painful to build well. And I think that you can do it, but again, the question becomes, hey, is that worth the investment of your time? And usually going and buying a solution is the better way. I think that's the value, is that, hey, you're going to save yourself a ton of time, and yeah, that's you'll end up with a better CI/CD solution around shipping infrastructure. I hope that answers the question.
Yep. It's clear to me. Thanks, Matt. All right, let's get this question from Aram here. How do you manage dependencies between root modules? Is it even possible without copy paste?
So that's interesting. I think that when you're referring to dependencies, you're saying, hey, I have a VPC that I'm deploying and I have a database that I'm deploying that needs to look at that VPC or run inside of that VPC, maybe run inside some of the subnets. And usually there's a hierarchy of ways to do this, but the suggestion that we always make is use data sources, try to decrease the amount of data that you're actually sharing. A lot of the times you don't even need to do that much data sharing between different root modules. But yes, it's possible without copy and pasting. You can use data sources. You can use Terraform Remote State. We try and suggest to avoid Terraform Remote State where you can. Sometimes it's totally okay to copy and paste that VPC ID if you're going that route, but you can also use data sources and get the same thing. And if another shout out to that naming and tagging. Hey, if you have very consistent names and tags, then you're able to easily find the resources that you're looking to reference within your downstream root modules. So
yeah. I had a question when you were talking about those labels and tags. Are there tools out of the box that support helping build naming conventions? Because I'd imagine that's very important to have a solid naming convention in those.
Yeah, so Terraform No Label is the one that we use. Been using it since 0.12, 0.11, and that is what we suggest. So we have 2 blog posts on that one. That is the way to do it. There are quirks with it, but we've written about them, and it's really worth checking out.
Cool. All right, we've got a minute left here, so we can maybe get to one more here. Let's see. All right, so quoted from an earlier question, do you have suggestions on how to handle multiple levels of configuration data in the context of IaC to keep things simple for teams?
How to handle multiple levels of configuration data in the context of IaC? I don't know what that's referring to. Maybe that means, I think it's probably referring to like, hey, you have variables that have defaults and then you have defaults that could be applied via TF-vars. I think that there's a hierarchy that we usually suggest there, but I would need to talk about that one longer. Yeah, sorry. Yeah. I know we're ending. All right. Great. Thanks for the time, folks.
Thanks, Matt.
Thanks.